this video, I am going to discuss some of the examples from the binomial distribution. This is chapter 14. First one. A fair coin is tossed 10 times. Let x be the number of heads that appear. What is the distribution of x? What is the random variable here? X. X is the number of heads. To check for the binomial, we should check 4 conditions. The first one, the experiment consists of a fixed number n of identical trials. How many times toss this coin? 10 times. Therefore, n equal 10. Then the second one, possible outcomes for each trial, success and failure. So how many outcomes here? 2 outcomes, right? It is head or tail. So second one is also correct. The third one, trials are independent. Yes, these trials are independent. Tossing a coin always independent. Therefore, the third one is also satisfied. The last one, probability of success. It should be the same for each trial. Suppose we are interested in getting head. So then, probability of head is the success probability. What is the probability of head? We use P for the success probability, then getting a head. So there are 2 possible outcomes total, therefore this is 1/2. This is the same for each trial. Probability of getting a head is 1/2 for each trial because there are 2 outcomes H and T. Right, all 4 conditions are satisfied. Therefore, X has a binomial distribution. Now how do we write this one? For the binomial distribution, there are 2 parameters. What are those? Binomial n and p. N is the number of trials, p is the success probability. So in this example, x, we know it is binomial distribution. Then what is the n? N equal 10. Then success probability 1/2. So this is the distribution of x, binomial distribution 10, 1/2. Then second example, a lot contains several thousand components, 10% of which are defective. 7 components are sampled from the lot. Let y represent the number of defective components in the sample. What is the distribution of y? So random variable is y. Y is the number of defectives. So here there are 2 possible outcomes. What are those? Defectives or non-defectives, right? Then this also can be a binomial. So how do we check? We need to check the 4 conditions. First one is n, identical trials. So here how many trials? Our sample size, it say 7 components. Therefore n equals 7. Then how many outcomes? We know there are 2 possible outcomes. What are those? Defective or non-defective. I say D O N. Third one, trials are independent. Yes, these components are independent. The last one, the success probability. Success probability is P. So what is the success probability? Right. Here, first go with the y. Y is the defectives component. Therefore, success probability should be the probability of defectives. Probability of defectives. So here, what is the probability of defectives? You see, 10% of which are defective. Therefore, success probability is the 10%. That means 0.1. Now we know all 4 conditions are satisfied. Therefore, y has a binomial distribution. Then how do we write this? You know, we write y has binomial 2 parameters n, p. So let me write this for this example. Here y has binomial. What is the n for this case? 7, and success probability is 0.1. So this is a binomial distribution.